So here to solve this challenging Killer Sudoku puzzle. It's one that has a lot of extreme values that come into play and also some locked sets that come into play. And what I mean by that is a group that has either one or all of its digits specified because of the context of other numbers around it. And so what really is key here is, as in many Killer Sudoku puzzles, is to be able to track the particular digits used in cages well and to be able to spot when you make some progress why the next constraints are going to pop up nearby in the puzzle. So to get started, it's obvious if the theme is around these large T's that some of the solve is going to start around them too, and you may recognize from experience that groups like the 16 have a locked set of digits, which is 1, 2, 3, 4, and 6. A group like 15 is going to have the lowest 5 digits, 1 to 5. And a 34 is, on the high end, a locked set, which is the digits 9 to 6, and then 4. And those are maybe the initial start of the puzzle. There's actually one sneaky step, which I'll put in here. I didn't discover it the first time I solved, but it's a pretty useful one to come up with, so as an advanced technique. When you're looking at the center column, you've got two really small locked sets already, and this should be a clue that these have to be very large digits up here in these three cells. And specifically, they're the only cells in this puzzle, in this column, that can be the 987. And so that lets you place this 4646 over on that side. And now, again, thinking about large digits, if we recognize that a 987 doesn't go into this cell, we'll come back. There's a simpler deduction here about this number to do in a second, but you can say that the 987 in column 6 go into these cells, and that actually means that the 6 in the center region is in one of those spots. And pretty early in the puzzle, although I think very few people get this early in the puzzle, are these two digits, which is this sure 4 and the sure 6. And it's worth thinking about globally, what about a puzzle like this would clue you into looking at these spots and getting this triple and then seeing the consequences of this triple in the adjoining spaces. So, if you get good at spotting this, eventually you'll be much better at Killer Sudoku puzzle than I was. I certainly took 15 minutes on this one and was much slower than the Grandmaster time. So this is the one area maybe of Sudoku puzzles where I'm a little slow. More typical starting point after seeing this 1, 2, 3, 4, 6 group is thinking about the 4 other cells in the same region, which are 5, 7, 8, 9 in some order, and the fact that in this spot neither a 7, 8, nor 9 can go in because there's not enough addition room left to get up to an 8, so you have to put in just a 5. The result is going to be a 1, 2 in some order here. And on the left side, although it's less useful at the moment, a 9 can't be up top because it would require just 2 cells left to add up to 2. That would be 2 1s, and that's not going to happen. So a 7 or 8 go in. Notice that whichever of these is true, one of these cells is a 1. The other may be a 2 or a 3. 7 would be 1 and 3. 8 would be 1 and 2. So that's at least the start of the puzzle, looking at these two T's. We haven't looked at the other T's, and we're going to need to pretty soon, but the glaring hook into the rest of the puzzle for me is at least this identification of a 1-2 pair, which says that any other digits in this column have to be slightly larger, 3 and above, and what I'm looking for are smaller cages in the same space that are going to be affected, and there's really one that's largely affected, and that's this 9. If this has to be 3 and above and 3 and above, there's not a lot of addition room left to still get a total sum of 9 out. There's an option of 3 with 4. That would give 2 remaining. And there's an option of 3 with 5, which would give 1 remaining. And that's really it. Notice that in either case, a 3 is required. And the remaining digit is a 4 or a 5. So this being the next note, now where's your attention drawn? Well, maybe it's up into this spot. There's some stuff to do there, like we do know the 5 is in one of those cells. But really, the critical spot is coming back to the theme elements, which are these diplomaties. And the 21, while itself is not a very remarkable sum, the other four cells in this region, if I told you those summed up to 24, that may seem a little more remarkable to you. And the reason 945 is the total sum of a group of 1 to 9, so it should be clear with some killer experience why 24 is a key sum. 24 makes you think 9 plus 8 plus 7. Typically, that's a 3-cell constraint, not a 4-cell constraint. But we have 2 cells that have to be very small. For instance, if a 3 were actually in this bottom cell, the largest sum you could get out was 5. 5 from 24 leaves 19. That's certainly a no-go, so the 3 has to come to the top anyway. But what you'll recognize is with a 9 plus 8 kind of logic, if these are as large as possible, we still need to get to a sum of 7 in the remaining cells, and that requires taking both maximums. It takes a 5 up here and a 2 down here to get a total of 24 in the other cells in this region. So we'll mark the 9, 8, which is required. Mark those results. Having marked the 9, 8, I'm going to mark what the other partners in these sum cages would be, because it's useful to think about. Now there could be something at this stage to do in the upper right. There's one thing I noticed right off the bat, which is that having marked 2 of the single 1s, it's useful to track 1s in others' cages. There can't be a 1 in the center cell because 1 and 10 is just not an option. 1s aren't over here, so there's certainly a 1 somewhere in that corner. There's more we can maybe do in a bit, but I'm going to jump to the bottom right now, and that's because this one actually really limits its other choice in this cage, which is a 10 in 3. Without a 1 has to be 2 and 3 and 5. The smallest sum, 2, 3, 4, is 9, and 1 above that is also a locked sum in these kinds of cases. So if 2, 3, 5 are dedicatedly in this group, the 3 option in that cell is just not possible. So I'm going to put in the 4, that gives the 8, 9 is above, gives a 5 above, and now I want to look back at this corner because we actually can do a fair bit here. The first thing we can probably try to do is to resolve which digits come into this 11 cage, and the reason I say that is we already have one of them, and the 2 remaining ones are going to add up to 10. There are 4 pairs that naturally add up to 10, 1 and 9. We can already exclude that because the 1 is in the cage and can't have 2 1s in the cage. The 3 is already in this region. There's a 3, 7 sum, but it's also easily strikeable. The remaining ones are 2 and 8 and 4 and 6. And early on in the puzzle we did this hard step to identify a 4, 6 pair up top. And the benefit of doing that is to recognize that you can't fit a 4, 6 into this cage as well, because the 2 spots up top are not used, so you need to put both the 4 and the 6 in row 2, not an option. So 2, 8, 2, 8, 2, 8 is the makeup of that group. The remaining digits in this whole space are 4, 6, 7, 9. Which of those add up to 11? 4 and 7 are the only set I see. A 4 in this column says. That's the only choice. We're now left with a 6 and 9. The 6 isn't in the top, so the 6 is over here. Get this sort of placement. That gives us that 9 there. That looks like I have this digit I could have placed earlier. But that gets us a pretty good chunk of this side. We hadn't done everything we could. Once we placed this 5, we have a note over here I'm seeing for where 5 goes. So 5 is there. The 3, 2 split like this because of that digit. We're most of the way over to the right side. We have a few things to think about still, but one of them is probably how we get to a sum of 9 up in this corner. Notice that the top row here is going to include a 3, 5 in 2 of these 3 cells. And also notice that a 4, which is in this top, is not going to be in the top group over there. And here you can think about the total set of sums that come up to 9 recognizing at least 3 or 5, maybe both, are part of the sum. And let me do that in a slightly easier way. If 5 is part of the sum, it has to be 5 plus 1 plus 3, which means that any potential sum that it uses is going to include a 3, so I'll just put a 3 in here. And a 3 that sums up to 9 is normally two choices, 2 and 3 and 4, or 1 and 3 and 5. And we know the 4 is gone, so we can actually make a deduction like that, which is that this is a 3, 5, and this is a 1. And that may not be actually the deduction that breaks apart the whole puzzle, but this is a kind of element of this construction, which is you have sometimes rather fixed cages to work on. The one that interests me the most right now actually is to look at the last of the t's. We've dealt with 3 of the 4 t's, but not this one. Here I'm going to do the same thing I did on the right side, which is to say that the other 4 sum up to 14. Look at that quickly. I have a 1. It's not telling me a lot about the others. It's sort of saying that these are in general smallish digits, but not super small digits. There's some range to get to 6s or even maybe a 7 or an 8. But there is something to do on the side, which is to still look at particular digits which we know something about and say where can't they go. And if you can assign a digit into a specific cage, that's almost always of high value to do. And I'm tempted most right now by this 2. And the reason is I know that a 2 can't come into this 13. 2 and 11, that's not going to work. A 2 can't come here. So I naturally have a suspicion that the 2's are going to be forced into this 31 cage. And I don't know very much at all about where they go. There are 4 spots that 2 could be. But it now is taking 5 cells that add up to 31 and making 4 cells remaining that add up to 29. And that should send some warning bells out to you if you've solved a lot of Killer Sudoku puzzles, that this is itself a forced set, which is 9875. And that means that the remaining 3 digits that are going to add up to this 14 are 3, 4, 6. So let me just quickly put those options in, and then we're going to trace out what they do in the adjoining cells and hopefully come to an interesting contradiction set. So 3, 4, 6 can give an 8, a 7, or a 5. The 5 is already here, so the 5 option is no good, which means the 6 option on the bottom is no good, which actually means that the 6 up top is forced to be in one of these spots. We could actually use that information right now to place these digits, although it's not critical that we do so. But we might as well. A 3, 4, 6 here. 3 can't be part of a 13 cage because 3 would come with 10. But the 4 and 6 are interesting. I'm going to be a little more careful than I sometimes am in doing this. I'm going to write these in a counterfactual way, which is to say that I'll make sure that in putting these sets, I have a consistent top and consistent bottom. So if the top is 4, the bottom down here can't be 4. We don't yet actually know that it's forced another way, but when we get over to this 12, you're going to see that we get a 2-form cycle. So with a 3, 4, 6 option here, the top can be a 7, a 6, or a 4. The 6 is canceled, so we're left with 3, 6. And the thing with this 3, 6 is you'll see that it's now a pair that is either 6 or 3. And if it's 3, it adds up to 7. So I'm going to put the 7 down here and that 4. And so it's more the case when you get a situation with 3 combos that work together, so this being a 4, 6, this being a 3, 6, and this being a 3, 4. There are 2 ways that the whole thing fills. It's 4, 6, 3, which is what you see up top, and on the bottom it's 4, 6, 3 in these spots with the results in the bottom. And the critical thing is this sense of what digits contribute to the other parts of these sums, that if you're choosing between the upper left world, as I'll call, and the lower left world in a hypothetical sense, seeing that you have the same digits here or the same digits here are both signs that there's a problem. In this case, this whole group is really, really troubled if you're in the bottom options, which means that you can actually resolve this whole set by just tracking the partial sums really carefully on paper. And the best Killer Sudoku puzzles will have deductions of this form. So thinking about when you want to trigger your notation to specifically key off that kind of uppercase, lowercase, or left case, right case, or however you want to mark it is pretty key. Getting all those values, like getting this 8, finally tells us some things about that side. These 3s give us a split up top here. The 6 we got gives us this other 6. We now actually know what's going on there. We've made enough progress to start actually breaking into the bottom. The bottom's a tricky place to get to, but things like the 6 at the start of the puzzle could have been either of two options of 1 and 5 and either of two options of 2 and 4. But this column now no longer has any force, so collectively there's a 4 in this group, and this group wants to be a 1-5, and the presence of these numbers tells us which of the potential options it is. We're still wanting to get what the sum in this group is, and I see that there's a 6 that has to come into one of these 3 cells. If the 6 gets into this cage, 4 and 6 is going to need another 3. That's no good anymore, so the 6 avoids that potential by coming to the top. That means the 2 is here, means the 2 is here, means the 2 is here, means the 2 is here. That now says this is 4-7 with a 9. We have this 9 and this 8 that we can place, 8 and 7. These are actually digits that could probably have placed a long time ago and just haven't. At this stage, most of the puzzle is solved, and so it's just tracking the final bits actually. 2, at the bottom is 3, 5, so this is 5 and 3, this is 3. 3 comes up here. This needs a 1, 6, the 6 is taken, so that's like this. I've actually filled the entry row in the bottom before I filled some of the other spaces, but I choose entry rows so I get a consistent group of 3, and so I wanted one here and one from the middle set, so don't think I made a poor choice there, although I'm sure we'll have some comments about it. Get these digits in, get into the middle space, get this 6 here. This needs an 8, 9, 7, 5, as we said before. It looks like the 9 is there. This is this 5. 5's in the center. We get 1, 4. Get 4. This needs a 3 and 7, which go here. And we've solved this puzzle. It's pretty challenging. It's also pretty remarkable and fun if you spot all the kinds of cute things Serkan did with it. The critical steps are, as always, extreme sums, this sort of we focused at the start with this 987 group and things you can do to actually place the 4-6 rather early. And then with the left and right side, it's thinking about both the set of 5 digits in this cage as well as the 4 digits outside of the cage and what that implies about the choices of digits. That gets through to the end. We don't have a lot of Killer Sudoku on the site in general, but it's a pretty common style for competition puzzles, so I hope you learned something about how to solve these, and particularly how to solve this challenging example. Thanks.